What if I told you that time, space, mass, even gravity, what if all the fundamental parts of our universe actually emerge from a single, almost absurdly simple rule? Well, that's the wild idea behind a new framework called the Relator Principle. And it doesn't just ask us to tweak our physics, it suggests the very fabric of reality is not at all what we think it is.
So let's just dive right in with a huge question. What if space-time, that whole four-dimensional stage where physics happens, isn't fundamental at all? What if it's just an effect, a kind of collective mirage created by a universal quantum rhythm that's happening underneath everything? Yeah, that's the radical idea we are digging into.
Now, to really get why this idea is so revolutionary, we've got to take a step back and look at a problem that has had physicists banging their heads against the wall for over 100 years. And that's the deep, seemingly unbridgeable gap between our two greatest theories of the universe. On one hand, you've got Einstein's general relativity. It's beautiful. It describes the huge cosmic dance of planets and galaxies, all moving through this smooth, curved space-time. And on the other hand, you have quantum mechanics, which rules the tiny, bizarre world of particles, a place of pure probability and weird quantum leaps. The problem? These two rulebooks are written in completely different languages. They just don't play nice together. At all.
But what if both of these amazing theories are just looking at the same thing from different angles? For decades, physicists have been finding these little clues, these tantalizing hints hidden in the quantum world that suggest maybe everything in the universe is secretly dancing to the same hidden universal rhythm.
Two of these clues are really big. The first one has this amazing German name, Zitterbewegung, which means trembling motion. It's this wild idea that particles like electrons are never really still. They're constantly jittering at an insane frequency, almost like they have some internal engine running at the speed of light. And the second clue? It's the idea of an internal clock. The theory goes that every single massive particle ticks with its own internal rhythm, like it has its own tiny, personal metronome.
Okay, so you have this internal jitter, this internal clock. These clues lead us straight to the core of the relator theory. It takes these hints and wraps them up into one super elegant idea that we can actually understand with a pretty simple analogy, a light speed budget.
The entire principle boils down to this one simple equation, r times omega equals c. What it's saying is that everything in the universe, from a photon of light to a giant star, is constantly evolving at the speed of light c. And this total evolution is just a mix of two things, an internal evolution, which you can think of as a particle spinning or ticking in place, and its external movement through space.
Seriously, the easiest way to get your head around this is to picture every particle having a fixed light speed budget. It can only spend this budget on two things, moving through space or its own internal ticking. But here's the key. The total spending always has to add up to the speed of light, no more, no less. So here's how that budget gets spent. If a particle is just sitting there at rest, it spends 100% of its light speed budget on its internal clock, just ticking away at its fastest possible rate. But the moment it starts moving through space, it has to take some of that budget away from its internal ticking and spend it on moving forward. And if something, say a photon, moves at the speed of light, well, it's spending its entire budget on that motion. There's nothing left over for an internal clock, which is exactly why, from a photon's perspective, time literally stands still. Okay, and this is where it gets absolutely mind-blowing. Just from that one simple budget rule, you can derive all the weird effects of Einstein's special relativity without ever needing to talk about space-time.
Right away, this explains time dilation. I mean, why do clocks tick slower the faster they move? In this new picture, it's not because time itself is warping or stretching. Nope, it's just a particle reallocating its light speed budget. The more of your budget you spend moving through space, the less you have for your internal clock, so it has to tick slower. Simple as that.
And this leads to a really profound shift in how we think. As the source material puts it, time itself is fundamentally absolute at the particle level. Time dilation isn't some strange property of a flexible spacetime. It's just a consequence of a particle shifting its light speed budget around.
And it doesn't stop there. Get this. This single budget principle is powerful enough to also derive one of the most foundational equations in all of physics, the energy-momentum relation. The one that connects mass, energy, and momentum. It just pops out of the math, a natural consequence of the rule.
So the theory nails special relativity, but what about the really big one? What about gravity? This is where the relativity framework makes its most stunning claim. It says you can explain gravity without any curved spacetime at all.
So, as we all know, Einstein's theory says that mass and energy literally bend the fabric of spacetime, and what we feel as gravity is just us following those curves. An apple falls because the Earth's mass creates a sort of dip in spacetime, and the apple is just rolling into it.
The relator theory paints a totally different picture. It says mass doesn't curve space. No. Instead, a massive object influences the internal clocks of the particles around it. Think of it like a huge magnet slightly changing which way a compass needle points. Mass causes this tiny little reorientation, a phase shift in a particle's internal rhythm. And it's that tiny internal change that guides the particle's path on the outside, creating the motion we call gravity.
Now, this might sound like a cool story, but does the math actually work? You won't believe this. Yes. Amazingly, yes. Using just the known constants for gravity, the mass of the sun, and the speed of light, the theory correctly calculates the exact angle that light should bend as it passes the sun. It gets the precise number that Einstein predicted and that astronomers have measured for a century, but it does it without ever needing curved spacetime. It's all just a result of those internal phase shifts.
So if this one simple rule can reproduce the effects of both special and general relativity, what on earth does that mean for our picture of reality itself?
This table really puts it all into perspective. General relativity says spacetime is the fundamental stage. Other cool modern theories like entropic gravity or loop quantum gravity suggest spacetime might be emergent, that it's built from something deeper. But the relator framework, it's in a category all by itself. It says we don't need spacetime to be fundamental or emergent. It suggests we might not need to postulate it exists at all.
This quote from the research paper says it all perfectly. The curvature of spacetime, the very thing we thought was gravity, is really just an effective description. In other words, it's a mathematical illusion. It's the shadow cast by the real engine of the universe, a deep, underlying, and universal quantum rhythm.
Which leaves us with a final, fascinating question to ponder. For the last century, we've believed the universe is fundamentally a story of geometry, of curves and lines on a space-time grid. But what if that's not it? What if the universe is fundamentally a story of music, a single, universal rhythm that everything, everywhere is constantly dancing to?